This is Chemistry 302, lecture number 10, calculating the pHs of strong acids and bases. With this lecture, we begin the process of understanding a very simple idea. What happens if I have a beaker and it's filled with water, which we know has a pH at room temperature of about 7, and I throw an acid in, or I throw a base in. It's key to understand that what I'm going to be doing for the next many lectures is simply throwing something that's an acid or something that's a base into water, and then I'm going to allow it to achieve equilibrium, and once it's achieved equilibrium, I'm going to say, what is there? What is the equilibrium concentration of those things that are there? Now, in the first lectures that we're going to be looking at, I'm going to be keeping things simple. So simple that I'm going to call them simple acid-base calculations. They're going to be calculations in which basically I throw a single acid into solution, or I throw a single base into solution, let them reach equilibrium, and ask what's going on. Now, there are a variety of things I can measure under these circumstances to ask what the equilibrium concentration is. But the thing we typically focus on is measuring the amount of protons, the amount of hydronium ion concentration. And we typically refer to this as measuring the pH of solution. So the game that we're going to play for a very long time is to be throwing acids and bases in the solution, letting them come to equilibrium and saying, what's the pH? So get prepared for this, because what's coming is going to happen over and over and over again for many lectures. How is it that we lecture for so long? Well, because it turns out that not only do I have acids and bases to work with, but when it comes to acids, there are a variety of different ways to define acids. I can define acids as being strong acids. I can define acids as being weak acids. I can also refer to acids as being polyprotic, to having more than one proton sitting on the acid. Same way with bases. Bases can be strong, they can be weak, they can have more than one hydroxide they're contributing. Then I can further complicate it by saying, let's not just throw one acid in, let's throw a couple of acids in, or let's throw a couple of bases in. Or I can throw acids and bases in at the same time. So basically what I'm going to be developing for you is the ability to throw a bunch of acids and bases into water, let them come to a pH, and then ask you the question, what is that pH? What's interesting is that we're going to develop some nice quantitative tools for doing this so that you can say, the pH is 7.2 or the pH is 4.3. But while that is more of an engineering exercise on a certain level, more of a mathematical calculation sort of level of understanding it, what I'm also going to hope to be teaching you is how to understand what's going on chemically in solution, so that you don't necessarily just have to do crank them out calculations. You can start to develop a sophisticated understanding of how it is that the chemistry, the actual structure of these compounds and the way they interact with each other ultimately results in there being dominating species that result, so that you don't necessarily have to say that the pH is 7.2 because you've done a massive calculation, but rather that you can say the pH is about 7.2 because you've made a variety of assumptions based upon your understanding of these compounds chemically, so that you can arrive just as quickly, or much more quickly, excuse me, at an approximate idea of what the chemistry of the solution is. So that's the underlying idea here, is that we're going to learn enough about the chemistry of what's going on here and the ability to make assumptions about what really matters in the chemistry of what's going on here, that we can start talking about what's happening at equilibrium, not just quantitatively, but also with a real feel for chemical insight.